Hello students, today we are solving a question on nucleus chapter. This is also a question from 22nd January shift 1 of JEE Mains 2026. The question says, the minimum frequency of photon required to break a particle of mass 15.384 AMU into 4 alpha particles is dash kilohertz. So we need to find how much energy is required by a photon such that if it is incident on this particle, it will break it into 4 alpha particles. Clearly the mass of 4 alpha particles is greater than the mass 15.384 AMU. Therefore, in this process, the energy of photon is getting converted into mass. Clearly this is a nuclear process because initially the particle is not an alpha particle and finally it's an alpha particle, which means its nucleus is now helium nucleus. So this is a nuclear process as the nucleus of the particle is changing its nature. And here in nuclear processes we should know that the energy of photon is not going to be conserved. Either some mass gets converted into energy or some energy gets converted into mass in nuclear processes. So in this case, of course, the energy of the photon gets converted into mass. So we'll use Einstein's energy mass relationship, delta E is equal to delta mc². Here, since the mass is given is in AMU, we will not use the traditional value of c². We'll use the value of c² to be 931 mega electron volt per AMU. So the energy lost in the process is the energy of the photon h nu, and the mass gained in the process is 4 times mass of alpha particle minus mass of the initial particle. Plugging in the values of h and the masses and putting the value of c² as 931 mega electron volt per AMU, we can get the mass defect or the change in mass is 0.624 AMU. 931 as it is, mega can be written as 10 power 6 and electron volt is 1.6 into 10 power minus 19 joules. If you calculate this, the only unknown is frequency and it comes out to be 1.4 into 10 to the power of 23 hertz, which is same as 14 into 10 to the power of 19 kilohertz. So according to our calculation, the option D is the answer, or fourth option is the answer.